In this video, I will discuss about integration. We will see what is integration and then how to do the integration and what are the rules in the integration, and especially we will focus on the indefinite integration for this video. So let us start. This is the learning objectives. So at the end of the video, I hope that you guys can understand the integration process as a reverse process of a differentiation. Before we study the integration, you guys have to understand about the differentiation, because integration is the reverse process. So if you don't know about the differentiation, please study about differentiation first. And then after that, I hope that you can integrate multiple types of equations, and then we solve problems involving the evaluation of constant of the integration. What is that? So let's see. Integration. Integration is as a reverse process of differentiation, or we call it as an antiderivative. So if the differentiation is a derivative of a function, when you do the derivative, that means from y, and then you change into the derivative dy dx. But in integration, we will do the reverse process. So we are looking for the original function before it's being derived. So I can say that differentiation and integration, the integration is the antiderivative. So it's the reverse process of the differentiation. As I mentioned before, to understand integration, you need to recall all the knowledge about the differentiation, especially for the algebra differentiation. So let's see, if we have a function of x squared, so we can find the dy dx of x squared is equals to 2x. If we have fx is x squared plus 3, we will have the derivative dy dx equals to the same, 2x. And also, when we have fx equals to x squared minus 1, the derivative of this is equals to 2x. So that means, if I want to find the antiderivative of the function dy dx equals to 2x, is x squared plus c. Why do I put c here? C is a constant. We call it as an arbitrary constant, because if you see, when I have x squared, the derivative is 2x. When I have x squared plus 3, the result of the derivative is still the same. The x squared minus 1, the result is 2x, the same. So that means, if I want to reverse this dy dx into the original function, it should become x squared minus 1. But on the second row, when I reverse this, I will have x squared plus 2. On the first row, if I reverse this, I will have x squared. So that means there are 3 possibilities or more possibilities when you do the antiderivative of a dy dx. it can be in the general form of x squared plus any constant that we don't know. You can see here the constant is 0. The constant is 3. The constant is -1. So that means we can find the general form. So it's an x squared plus c. Yeah. So next, if we have x cubed plus x squared, the derivative is 3x squared plus 2x. If we have x cubed plus x squared plus 3, the derivative the same. And also for x cubed plus x squared minus 7, the derivative is still the same. So the antiderivative of 3x squared plus 2x is x cubed plus x squared plus c, the arbitrary constant. This is the same explanation. Why do we put c there? Let's see the other one. If we have 2x plus 5 to the power of 8, the derivative will be equals to 16 to x plus 5. Yeah. So we move the power into 8 times the power u minus 1. Yeah. So 8 minus 1 is 7. And then multiply it with the derivative of the inner function. So times 2. So becomes 16 to x plus 5 to the power of 7. And if we have 2x plus 5 to the power of 8 minus 1, the dy dx still the same. If we have 2x plus 5 to the power of 8 plus 3, and it has the same result for the derivative. So that means the antiderivative of this dy dx is 2x plus 5 to the power of 8 plus c. How if f(x) equals to ln 2x? The derivative is 1 over x. The derivative is 1 over 2x times the derivative of 2x, which is 2. So it equals to 1 over x. Ln 2x minus 1, the derivative will be the same. So that means the antiderivative of 1 over x is ln 2x plus c. And if we have ln 2x minus 1, the derivative will be 2 over 2x minus 1. For y equals to ln 2x minus 1 plus 2, the derivative will be the same. And the antiderivative of this is ln 2x minus 1 plus c. How about e, exponential? So the derivative of e to the power of 3x is 3e to the power of 3x. E to the power of 3x minus 1, the derivative will be the same. So the antiderivative of 3e to the power of 3x is e to the power of 3x plus c. E to the power of 4x plus 2, the derivative will be 4e 4x plus 2. E 4x plus 2 plus 2, the derivative will be the same. So the antiderivative of this is e to the power of 4x plus 2 plus 6. The f prime x is the symbol for the derivative of an original function. So that means, in opposite way, the antiderivative of f prime x is the original function, the primary function, fx. And this is the symbol of the antiderivative. We call it integral, indefinite integral, because it will contain the constant c. So the antiderivative or the integral of f prime x, f accent x, dx is to the respect, with respect to x, equals to the original function plus arbitrary constant. Every integration notation should be contain the dx, because you have to know in which variable that the function will be integrated. So c is called an arbitrary constant. Now, what are the formulas for the integration? So first, we have the power rule. Power rule is for the first example. So for every equation ax to the power of n with any numbers except for -1. So the integral of ax to the power of n is a over n plus 1 x to the power of n plus 1. So again, for example, if we have x squared, when we derive it, it becomes 2x. Now, how do we return the 2x into x squared? So in here, we can see that the power should be n plus 1. So that means in here, it is 2x. And then the power is 1 plus 1, and then divided by the new power plus c. So the result is x squared plus c. So we add the power first and then divide it into with the new power. Another example, x cubed. When you derive it, it will become 3x squared. So when you want to reverse this process, so 3x squared, and then you add the power by 1, and then divide by the new power. So it will equals to 3x cubed over 3. So equals to x cubed plus c. So this is the original function. This is called power rule, applied for ax to the power of n. And n should be any numbers except for -1. If we have this form, the same for n is not -1, so we will have to do the same pattern. So we add the power by 1. We add the power by 1 first, and then we divide it by the new power, and also divide by the derivative of the inner function. This is opposite way. of the derivative. For example, 2x plus 5 to the power of 8. When you derive, you will have 8 times 2x plus 5 to the power of 7 times derivative of the inner plus times 2. Now, this is equals to 16 2x plus 5 to the power of 7. Now, I want to integrate 16 2x plus 5 to the power of 7 dx. So the result should be back to this. So how do I do that? So I copy this. And then, according to the rule, I have to add the power by 1. So in this case, I will add the power by 1. And then divide it by the new power. So I divide by the new power. The new power is 8. Yeah, 7 plus 1. And also divide by the derivative of the inner function. So I divide by derivative of this function, which is 2. So as the result, I will have 16 over 16, 2x plus 5, 8 plus 6. So equals to 2x plus 5 to the power of 8 plus 6. So this is exactly the same. Yeah. Next. Now, how if the n is negative 1? So the integral of the power for x is negative 1 is 1. Because we know that, for example, if we have ln x, the derivative is 1 over x. So integral of 1 over x dx should be ln x plus c. If I have ln 2x, the derivative will be 1 over 2x times 2. So the opposite way of this is ln 2x plus c. How do you do that? You have the 2 ln 2x divided by 2, the derivative of 2x. Yeah, so you will have 1 here, ln 2x, and then plus c. And you do the same thing for this form. So it will be 1 over a ln ax plus b plus c. How about the ex? We know that the derivative of ex is still the same. So the integration of ex is still the same, ex plus c. And ex plus b, when we derive it, we multiply it by a. So when we integrate it, we have to divide by a. Okay, this is example. So we can use the formula on the right, on the top right, yeah? Integral to x to the power of 5. So 3x to the power of 5. We add the power by 1 and then divide it by the new power. Plus integrate 5x4. So 5x4, add the power by 1, divided by the new power. Let's see. So the result is 1 over 2 x to the power of 6 plus x to the power of 5 plus c. So try to derive back. When you derive this, you will have 3x5 plus 5x4. Yeah, so this is correct. Yeah, when you have addition, you can integrate it individually. So number 2, integral x minus 2 plus 4. So I can have this. So that means the x to the power of negative 2, I will add by 1 and then divide by the new power. The new power is negative 2 plus 1, so negative 1. And for x, so this is to the power of 1 plus 1 divided by 2. So this is 1 over negative 1, x to the power of negative 1, and then plus 2x squared plus c. So equals to negative x, negative 1, plus 2x squared plus c. Number 3. So we have to change this into 2x minus 4 minus 1. Integral dx. So this is equals to 2x minus 4 minus 1. So I add by 1 divided by the new power, negative 4 plus 1 is negative 3. And 1, so I just add x. Yeah, for the constant, you only add x plus c. So it's negative 2 over 3x minus 3 minus x plus c. Number 4, so it's 5x to the power of 3 over 2. So we plus 1 and then divide by 3 over 2 plus 1 is 5 over 2. Plus 2x to the power of half. So this is plus 1 divided by half plus 1 is 3 over 2. So the result will be 2x 5 over 2 plus 1 4 over 3 x to the power of 3 over 2 plus 6. This is the answer. Number 5, the same. Change it into 2x to the power of minus 1 over 3 minus 4 over 3 x to the power of negative 3. So we need to add 1, yeah. So plus 1 divided by negative 1 over 3 plus 1 is 2 over 3. So 2 over 3. This one plus 1 is negative 2, so divided by negative 2. So the result will be 3x to the power of 2 over 3 plus 2 over 3x minus 2 plus c. For number 6, we can use this formula. Yeah, the same. So for x plus 1 to the power of 7, we add the power by 1 divided by the new power, 8, and then divided the derivative of 4x plus 1, which is 4. So divided by 4. So equals to 1 over 32, 4x plus 1 to the power of 8 plus c. Don't forget the arbitrary constant, yeah? 7, the same, 3x minus 1, negative 4. So plus 1 divided by negative 3. And then divided by the derivative of 3x minus 1, 3. So 1 over 9 3x minus 1, negative 3, plus c. Number 8, it's 2, 3x minus 5 to the power of 3, negative 3. So, plus 1 divided by negative 2, the new power. And then derivative of 3x minus 5 is 3. So it's negative 1 over 3, 3x minus 5 to the power of negative 2 plus c. Next, for this, still the same, yeah? For 2x plus 5 to the power of negative half. So add the power by 1 and then divide it by negative half plus 1 is half. And then divided by the derivative of 2x plus 5 is 2. So for 2x plus 5 to the power of 3 over 1 over 2 plus c. Number 10, it's 2 over 3 x minus 1. So plus 1 is 0. So we divide by 0, cannot. Yeah, that's why for x to the power of negative 1, we will use this. So it becomes ln. Yeah, so this is this. So this is become 2 over 3 times 1 over x. Integral. Now, integral 2 of 1 over x is ln. So 2 over 3, 1 over x dx, 2 over 3 ln x plus c. 11, 2, 3x minus 5 to the power of minus 1 dx. So we integral it to, this one becomes ln 3x minus 5. Don't forget to divide by derivative of 3x minus 5, 3 plus c. 12, e to the power of 4x. So e will be stay the same, divided by the power 4 plus c. This one, negative e minus 3x. So we divide by the power, so over negative 3 plus c. So it's 1 over 3 e minus 3x plus c. And then for this one, we are looking for the constant c. We know that f accent x to x plus 6 passing through the coordinate. So we can just integrate, find the original function first. We integrate to x plus 6 dx. And this is equals to x squared plus 6x plus c. And how do we find c? Replace the coordinate negative 1 and 4. So we put 4 equals to negative 1 squared plus 6 times 1 times negative 1 plus c. So 4 equals to 1 minus 6 plus c. So c equals to 9. So that means the equation is x squared plus 6x plus 9. 15. So integral 6x squared minus 6x plus 5 dx. So this is 2x cubed minus 3x squared plus 5x plus c. And then replace the b. So it's negative 3. This is fx here. Equals to 2 times 1 cubed minus 3 times 1 squared plus 5 times 1 plus c. So c here is 2 minus 3 is negative 1 Negative 1 plus 5 is 4. 4 minus 7 is negative 3. So C is negative 7. So this is 2x cubed minus 3x squared plus 5x minus 7. So there is no more constant C here. The last one, it's integral to 6x plus 3 minus half dx. So it's 2, 6x plus 3. The power plus 1 become half. So divided by half and then divided by 6. Let's see. So this is equals to 4/6. So 2/3, 6x plus 3 to the power of half plus c. And then we replace 1.1, 2. So 2 equals to 2/3, 6 times 1 plus 3 half plus c. So c equals to 6 plus 3, 9, so 3, so 2, so c is 0. So the equation is 2/3, 6x plus 3 to the power of half. That's it. Yeah. So I can just replace the coordinates since because this is always the original function. And I have exercise for your practice. And that's all. Thank you.